Welcome to another Graphical BASIC tutorial. This is part 17 of the PIC18FxxQ41 chip family. We are well into the tutorials. This is number 17 and we're going to be looking at the tool chain. Take a slight diversion into some technology, but we're going to look at how it all works. Well, I've been using a microchip low pin count demo board. It looks like this. I've had it on the bench here for a week or so now, and next to it I've got a little one. I've got a microchip express board, and I'm going to show you some code portability later on. So let's have a look what Graphical BASIC compiler is. Invented by Hugh Constantine in Australia when he was 13 years old. It's been around a very long time, and it's now an open source development for microchip PIC, microchip AVR, and LGT, so that's Logic Green Technologies of China. They're 8-bit microcontrollers. We've now enhanced it to support the 18FxQ41 chip family. The reason for that is there's a slight underpinning change required to make it work, which I will show you in the next tutorial. So Graphical BASIC is a cross-platform with common code translation. What does that mean? It means that it works across PIC, AVR, LGT. It works across the subgroup in those 8-bit chips of 10F, 12F, 16F, and 18F. There's 5 different families of AVRs and another LGT, and it works across the same code, works across those families. And I'm going to talk about code translation later on. I'm going to take a very simple piece of code that worked on the 18F, and I'm going to make it work on a 16F by changing 2 small parameters, and they are very obvious parameters. Now, Graphical BASIC also comes with a Graphical BASIC, which is a drag and drop. You can see on the screen there. It is for educational purposes, and it gets you into programming. It's extremely simple. You get all the standard logics of flow control and assignments. You get the UI itself, the user interface. It uses the same underpinning compiler, and you can use code generators like PPSTool and all the programmers that are defined within the toolkit. You can use other code generators like CPLC, I'll explain that one is, and there's another one called PSMC. I won't be explaining that one, but it's available as a code generator that you can then insert into your Graphical BASIC, Graphical BASIC source code. Well, this week I've been using the Windows IDE. It looks like this. It's a simple compiler at the bottom and with an IDE put on the top. We have programmers. I'll be showing a whole list of programmers shortly. And we have an IDE that is based upon SynWrite executable, and it's been adapted through GS+Tool to control programming events and other reports. Well, we have a little tool in there called the Program Editor that helps you control the programmers, because you can have many different programmers selected at once, and it will make decisions to ensure that your programmer is right for the chip that you're trying to use. We have PPSTool, we have CPLC again, PICInfo, which I will be showing you, GS+Tool I've already spoken about, and there's Terminal. You can add your own tool in, but these are the ones that come in the box. The full suite looks like this. It's an extensive suite, and if I go to my desktop, I'll just pop to my desktop and type in Excel. In Excel, I have a spreadsheet, and that spreadsheet will show you all the different tools we've got. I can filter it. I can look at, okay, what do we support in terms of IDEs? Well, we support, this is the software we use for IDEs, but let's have a look at what we do for programmers. For programmers, we support an awful lot of programmers, from AVRDude through to MPLAB IPE. If we look at code generators, CPLC Tool Designer, PICInfo is a code generator, PPSTool is a code generator, and PSMC is also a code generator. They generate code that you can paste into your source. If I look at linkers, compiler linkers, well, the only one is Graphical BASIC, Graphical BASIC with the IDE. It takes the basic code and it will create you a hex. What about other? And I've already spoken about SynWrite. So I can use this as a filter to sort of show you some other things. If I want to show you how many linkers we support, well, we support PICAS for microchip, MPASM and GPASM. And I'll show you exactly how we do that tomorrow. So what we've got is a tool suite that is documented, supported by a huge community of people and other vendors. Let's go back to PowerPoint. So let's have a look at the core compiler, what goes on inside of that core compiler. Well, we've seen that we take source code and we generate a hex file. Well, how does that all happen? Well, we take the source code here, and that is the listings that we've been working on, and it takes libraries into what's called a preprocessor. When you say make me a hex, it joins them together into a solution. It checks the basic syntax. It goes into a code translator, and that code translator orders the code, puts it in a neutral language, but optimizes the code. Now, optimization is pretty extensive. Then it will start to generate in the assembler assembly code specific to your chip selected. In our case, it's an 18FxxQ41. If it was a 16F, it would be 16F, 10F, 12F, AVR, exactly. So these are, at this point, we're starting to generate the code specific for the chip, and at that point, it will output an assembly language file. It will also output the reports. Then it passes it to GCASM, Graphical ASM. It will then link it and create the machine file, which you've seen happen, and then it will get programmed. Well, what happens if you didn't want to use that, or you wanted to validate what's going on? Well, you can easily cut off the operation of the compiler after the assembler. It still does all its normal work. It will output an assembly file, and then you can push it into your own linker. Linkers like PICAS, MPASM, MPLab IDE, GPASM, and it will then generate a hex file. And I'm going to show you some of this tomorrow in the alternative assembly tools. We also support Linux, BSD, Mac and Pi, which isn't shown on the, they're slightly faster. You're going to have to go out and find programmers, come to the forum. You're going to have scripts, but we supply those as packages in the distribution. So they're all available, and you can do most things on various different operating systems. They work really well. It's open source. Take the code, develop it, and add some value to it. So what I want to do very quickly, I want to show you PICInfo tool. I want to review PPSTool one more time. I'm going to show you some preferences, and then we'll have a quick demo of CCL tool. Okay. So let's have a look at PICInfo. PICInfo is on the screen now. I've zoomed in and I'm just toggling to it here. And there's an extensive list of PICs in here. I just want to pick the one I'm talking about, the Q41, just to show you this. These are the options here, and this is a code generator. So if I wanted to change my code protect, my CP, I would set this to on. I would copy that config, and then I can paste that into my editor. I will just show you my editor here. I can paste that code into my editor, and look, CP is on, and it would work fine, because what the star means in here, that's the default value. So if I reset it, it will go to off. There's other tabs in here, and it shows you the configuration of the chip in terms of memory, EEPROM, RAM, number of pins, etc. Lots of parameters in there. We show you the raw data for the configuration or the options. You can go through and look in there. Registers are fully listed. The bits of the registers are also listed. And then finally, the interrupts. And if you want to use an interrupt, you need to use these codes here. Graphical BASIC handles the enable bit and bit events for you automatically. And so if you wanted to use external interrupt 0, you would use int 0 and it would work for you. But you can also use PICInfo to get to other tools like PPSTool. PPSTool is now loading. I will zoom in on PPSTool. There's the right icon. There we go. And that is now preloaded my chip in here, and there's lots in here as well. But it is a subset because not every chip is PPS. And we've seen that we can take inputs and outputs and assign them to ports. Add it in. This generates code. I'm doing it randomly. I can copy that. I can then toggle out to my program, and I can paste the code in. They generate code. They save hours and hours of wading through the data sheet. The important thing about PICInfo, it's got some other capabilities in there as well. If you want to get to the data sheet, click the data sheet and it will open up the data sheet for you. Let's see if it's opened it up for me in the background. I think it has. It's doing it in the background for me. There's the errata. There we go. So it's opening up the tools exactly on the PIC web page. Very quick to get at the assets of microchip assets. So that's pretty useful to use in terms of getting at those particular specific pieces of information. And then if you want to get to the IDE, you can get to the IDE, which we've seen. But I want to take you to the Preferences tool. That is also available via the IDE. But let's have a look here. If we look at the Preferences tool, I'll zoom in on that for you. Let me just bring that down as a zoom in on that. There we go. We got it on the screen. Well, it brings up a whole series of programmers. There are many different programmers defined in here, and there are two lists. There's a programmers in use and programmers, other available programmers, and I've got them they're in order of preference. It will automatically select an express board if the chips are 16F, two types of 16Fs. It will select PIC Plus, then it will try to pick an LGT, Northern Programmer, Tiny Bootloader, etc. This is very simple to use. To move the priority, you literally drag and drop it around. And if I wanted to make Northern Programmer work, I would take it to the top. And well, I don't. What I want to show you that I've got an express board attached, and I've got my PIC kit there. I can then put it in, and there's parameters in here that you should look at, try to understand, but they're relatively simple. Also in here, you can show the basic code in the assembly, and you can have a verbose mode, which means it will show you more information. I'll turn that off. But I've not changed my setup because I want to show you something in the IDE. So I've checked my setup, and I'm going to go back into the IDE, and I'm going to do some programming. So off to the IDE. It's opened up the IDE. Let's have a look what's going on. So I've got a chip here, a program. It's actually demo 30. I'm just going to program that out to the board. It flashes, and you can see that the LEDs have just flashed, and I should have an LED pulsing every 100 milliseconds. I have. I've also got attached a 16F. So what I'm going to do up here to show you code portability is I'm going to change that to a 16F. I'm going to change the LED port, and I'm going to program it. And you will notice there is a very small LED in there, and it has just started flashing. That was not flashing before. I will stop. I will change its pulse so that you can see it to 1 second, reprogram it, and this LED will change to a slower pulse. On, off, on, off. My point there is Graphical BASIC has just changed the code, the underlying assembler for that particular, for the 2 target chips. One moment I had a 18F, the next moment I had a 16F. Very simply done. And you can do that in Graphical BASIC across the whole suite. So I want to go back to PowerPoint to see where we are, because I've just shown you PICInfo. I've shown you PICInfo. I've shown you PPSTool, edit preferences. Let's look at CLC. So CLC, I'm going to show you how to use it, just to show that you can use code generators in other places and other tools just to paste them into Graphical BASIC. Well, CLC is a series of basic gates and sequence logic options that can be customized in your specific applications. Those logic gates, and there's 4 of them, allow you to combine signals together to create a custom signal with absolutely no CPU overhead. I'm going to make a very quick program to turn on the LEDs of that on that board with no CPU code. So how am I going to do it? I'm going to tell it that it's got an input of on RA3, and it's going to do an OR, what is it? It's OR or XOR. It's going to come through, and if I put a high input on RA3, the output will come to a high as well. You can use this to generate specific outputs. I've used it many times on pulse width modulation that are very specialized, but it does work very extremely well, and I'll show you how to do it very simply. Let's go back to some code, some sample code that we've got. I've given you a sample program. Here it is, and essentially I've got the standard chip at the top, and I have told it in PPSTool that I want to take the input of CLC 0, and I'm going to take that on RA3, and I want to put the output of that CLC on all 4 LEDs, RC1, RC2, RC0, RC3. I did that in PPSTool, generated the code, put it in. I then said I want an XOR gate inside of CCL tool, and I want the input to be RA3, and I want the output to be a XOR. Then all I've done is I've said, as before in all the other demos, I've set the outputs. I've set the outputs for the LEDs and the input for the switch. And if I now code that up and reprogram it, you will see it flash. Now it's doing nothing. Why? Because I have no code in here. It's a do loop, and it's going to do that forever. But the CLC enables me, when I push RA3 switch down, the 4 LEDs come on. So I have created a logic gate inside the chip with no processing power. Proof that you can set the registers directly, and I took those from CLC tool, pasted them straight in. There was no changes to them, and I've used code generator in PPS to set up the input and the output. Graphical BASIC uses every tool known to man to make it work. So I wanted to show you the toolchain, extensive toolchain, high-level overview of how the compiler works. I think I've done that. Tomorrow we'll be looking at assembly and assembly alternatives, and we'll actually be looking at MPLabX and how we can use MPLabX. With that, enjoy.